All right, if we're lucky, I'll get actual 3 and 1 done in this video, but we shall see. So the first one is number 6. I'm going to graph these guys. The first guy, if I factor out a y, I'm left with y minus 5. So he has y-intercepts of 0 and 5. And then because the y squared is positive, I know it opens to the right. Whoops, didn't mean to do that. Hang on, let's see if I can fix the frame here. Got it. Okay. So then my second guy, he can factor out a y, so I'll have y minus 3 minus y. So I have y-intercepts of 0 and 3, and this guy faces the other direction. So here is my intersection, and I know that one of my intersection points is 0, and I don't know the y value of the other one, so I need that. So let's go ahead and set these two equations equal to each other, and I'll get 2y squared minus 8y equals 0. Factor out a 2y, and I'll be left with y minus 4. So the 2 points of intersection are at 0 and 4. Those are my limits of integration. And then I need right curve minus left curve. My right curve is 3y minus y squared, and my left curve is y squared minus 5y. So let's go ahead and clean that up before we integrate. So I have negative y squared minus y squared is negative 2y squared. And then 3y minus a negative 5y is 8y. So let's go ahead and integrate by hand. So we'll get negative 2/3 y cubed plus 8y squared over 4. So 4y squared, all on the interval from 0 to 4. So now let's plug in the 4, and I'll get negative 2/3 times 64 plus 4 times 4 times 4 is 64. When I plug in 0, they go to 0. So then this will give me negative 128 over 3 plus this is 192 over 3. And that looks like I'm going to have 64 thirds, and C is going to be my answer. I'm going to go ahead and copy this over so now I have a better view of problem number 7. So problem 7 says, let's go ahead and find the intersection of these two curves. We need to find the area in between them. So y equals 2 over x looks like about like that, and it has another branch down there. And then x plus y equals 3 is really y equals negative x plus 3. So that has a y-intercept of 3 and an x-intercept of 3, and it looks like this. So clearly I have not drawn my green graph very well, so I'm going to fix that. I only need the first quadrant of it drawn. And I know that if I plug in x equals 2, I'm going to get out 1. So that'll be right there. And if I plug in x equals 1, I'll get out 2. So that'll be there. So that's much better. And I actually have an intersection. So I need top curve minus bottom curve here. The linear curve is the top curve. So negative x plus 3 minus 2 over x dx. My limits of integration, I need to find the intersection point between these two. So 2 over x equals negative x plus 3. Let's cross multiply to get 2 equals negative x squared plus 3x. Now let's go ahead and subtract 2 from both sides. Oh, to make our lives easier, let's multiply through by a negative 1. And now let's factor to x minus 2, x minus 1. So my limits of integration are 1 and 2. So let's go ahead and integrate to get negative x squared over 2 plus 3x minus twice the natural log of x from 1 to 2. So when I start evaluating that, negative 4 over 2 is negative 2 plus 6 minus 2 ln of 2. Subtracting out all of negative 1/2 plus 3 minus 0. So when I start to combine all of these, negative 2 plus 6 is 4 minus, did you see I wrote the ln of 2 and I meant to write twice the ln of 2. Whoopsie. Okay, 4 minus twice ln of 2 minus, and it looks like it's 5/2 combined in there. So when I have 4 minus 5/2, I get 3/2 minus 2 ln of 2, which I'm hoping has an answer up here, and I see it because if I bring up the 2, I end up with 3/2 minus ln of 4, which is E. So let's go to another page to do problem number 8 now. And we have the first quadrant bounded below by the x-axis and above by the curves of sine and cosine. So here is sine, and let's see, cosine looks like that. All right, so they want to be bounded by the x-axis and then above by the curves of sine and cosine. So it's right here is our, oops, I lied. I'm actually going to undo that. Above by both the curves sine and cosine is actually going to be right here. So my limits of integration are 0, and then where cosine hits the x-axis is pi over 2. So I'm integrating from 0 to pi over 2, except now that I'm doing this problem, I think I've got a line of symmetry right there. So if I integrated from 0 to pi over 4 and doubled that integral, my life will be a lot easier. So let's do that. And integrate from 0 to pi over 4, double it. So I'm just integrating the sine function. Sine integrates to negative cosine. So I'll have negative 2 cosine of x from 0 to pi over 4, which is negative 2 times the cosine of pi over 4, which is rad 2 over 2, minus, and I need a big bracket around this, minus cosine of 0, which is 1. So when I multiply this out, I get negative 2 over 2 cancels. So I get negative rad 2 plus 2, and my answer is going to be A.